Well, here in problem 10, we've got three sets, and there's a little bit of set theory here. What we're going to do is we're going to find the union, this is the union right here, and the intersection of these three sets. Now, let's be sure we know what the union and the intersection are. So first up, why don't we be sure we know what a set is? So I've got the definition here. Now, let's just read it over. A set is a collection of objects or things. Now, there's a little bit more to it than this. It's a collection of objects. These objects have to be distinguishable, all right? So I'm going to put in here distinguishable. You have to be able to distinguish one from the other. So you have a collection of objects. Now we have that here, right? Look at these objects. I got a 0, 2, 4, and 6. Now those are all distinguishable objects. If I'm pointing to this one, I know it's not a 0, right? I can distinguish one from the other. Same thing over here. I've got 5 objects, 1, 2, 3, 4, 5, and they're all distinguishable. I can tell which one from which. Same thing over here in C. I can tell 1, 3, 5, and I can tell them all apart. Now what I'm getting at is that if I was to put in some other number, like suppose I did this. Suppose in A, I put in another 4. All right, that's not really a set, because then I have two objects right here that I can't distinguish one from the other. A 4 is a 4. All right, so that would not be a set. So let's remove that. And now I've got three sets, right? A set is a collection of objects or things. The objects in the set are called the elements or members of the set. So in the first set, I'm calling it A. Just give it a name, usually a capital letter. The objects in here, I'm going to call elements or members. So this has, set A has 4 members, set B has 5 members, set C has 4 members. Now, just as we can with numbers, we can perform operations on sets. Like in numbers, what do you do with numbers? You can perform operations, right? You can add, subtract, multiply, divide, raise the powers, take their roots. And we don't do those operations with sets. We have different operations. Here's the first one. This one is called the union, all right? Now, the union is this. The union of two sets, A and B. Now, A and B can be any two sets. Written A, that's a special font. It's kind of like a U, right? But it's not really a U. It's a special font. It means union. A union B. This is the set of all elements that are either in A or in B, or in both. Now, in mathematics, the or is inclusive. So if I just said in A or B, it means it could be in both. All right, so what is this? A union of two sets you combine these sets together where you just take all the elements in one and all the elements in the other. Now let's do that up here. You see up here in this problem? Well, we can't do it yet, so let's hold on. But I will do this with an example. Suppose that we have this set here, A, and I want to union that with B. Now, here's set A. I'm going to write this out explicitly. It's 0, 2, 4, 6. And I'm going to union that with B. Now, B is 1, 2, 3, 4, and 5. So I'm going to get a new set, and I'm going to call it A union B, and that's going to be equal to, now look back over at the definition. What do I put in here? Well, I put in all the elements that are in either A or B. All right, so come over here. Everything that's in A is going to go in, and everything that's in B is going to go in. So everything in A, as long as it's in A, it can go in. So in A, what do we have? We have 0, 2, 4, 6. But now also everything, if it's in B, it can go in. Everything in B is going to go in. So what do we have in B? All right, so here's B over here. 1, 2, 3, 4, 5. So put in the 1. All right, we'll put in the 1. Now what about this 2? Well, I don't need to put the 2 in here because I already have the 2. So the 2 would be in here because it's in either or both A and B. And in fact, if I did put a 2 in here, it would no longer be a set, right? Because I could not distinguish this 2 from that 2. So 2 is already in, but 3 is not. So let's put a 3 in here. And what about the 4? Well, the 4 The 4 is already in here, right? The 4 is already in here. And that came from set A. So I don't need to add the 4 again. But I will put in that 5. And that should be it, right? So what's in the union? Well, the union, if you pick any of these numbers in here, you should be able to find one. You should be able to find it in either or both of these sets. So just pick a number, like 1. Well, 1's not in A, but it is in B. It just has to be in at least one of them. All right, that's the union. Now, there's a little bit more down here. Look at this part here. Look at all these symbols. All right, look at all these symbols. Here's what this says. Instead of saying this in words, in sentences, or, English words, we can say it mathematically like this. X is going to be an element. Now, that symbol right there, that means element. Now, it looks like an E, but it's not an E. It looks like maybe a Greek letter epsilon, but it's not an epsilon. It's its own font. It's a Set 30 font, and it means the word element. Or, if you like, member. Right, now here's what this says at the bottom. Let's just read through it. I mean, it's like a different language here. We just have to learn how to read the language. What does this say? X is a member of this set, right? So remember, A union B is a set. So X is in this set, right? Like X is a member of this set, if and only if. That means, we'll talk about that in a minute. So X is in this set if, over here, look at this. X is in A, or X is in B. All right, so let's look over here at this example. At the example we just did, I'm going to do this at the bottom right over here. Now, what about 4? Right, so if I look at 4, I'm going to say 4 is an element of A union B. And why is that true? Now, that's going to be true if, I won't say if, you know what I'm going to say here? I'm going to say since 4 is an element of A, or 4 is an element of B. Now, is it true? Is 4 in A or B? So you look at the A and B. All right, I look at A. Yeah, 4 is in A. And it turns out it's in B. So it is in at least one of those. Now, what about this if I choose 5? Okay, could I say 5 is an element of A union B? Well, that's going to be true since is 5 an element of A, or 5 is an element of B. Okay, it's an or, so read it carefully. It's an or, and an or means it has to be one or the other, or maybe both, but it has to be at least one of them. Is 5 in A? Is 5 a member of A? You come up at A? No. All right, so 5 is not in A. Is it in B? I look at B. Yeah, 5's in B. All right, so 5 is in B, so this works. 5 is in at least one of those, so 5 is in the union. Now, what about, do this at the bottom right, what about 7? So I'm thinking, okay, is this a true statement? Well, I'm going to say it this way, all right? 7 is an element of A union and B. Now, if I want to negate that, well, first of all, is this true? Is 7 in A and B? Now, this would be true if 7 is an element of A, or 7 is an element of B. Is 7 in A? So you look back over here at A. Here's A, back here at the top right. 7's not in that one, so that doesn't work. Is 7 in B? No. All right, so this doesn't work, and this one doesn't work. All right, so 7 is not in either A or B. It's in neither one of those. So here's how we're going to say that. We're going to say 7 is not an element of A union B, because it's not in either one. Right? So what do? You just say this. Take the element sign, you draw a line through it, right? It's not. That means not an element. I'll abbreviate, ELT. Here's another set operation. It's called intersection. Now, you can probably get a good feel for this one, because when two things intersect, they overlap. So this is going to be where two sets overlap, what's common to both. So here's the definition. The intersection of two sets A and B, written, now you just take that union sign and flip it over. That means A intersect B. All right, here's what it is. It's the set of all elements, numbers, that are in both A and B. So now the key word here is and. Right, so when you see this intersection sign, you think and. When you see this sign here, you think or. Okay, So let me actually write that. It's in those definitions. But when you see this, you think the English word or. When you see this, you think the English word and. So let's go back down to the definition, see what it says. The key word is and. Now, for element to be in A intersect B, all right, here's the definition now. X is going to be, right, X is a member of this set, A intersect B, if and only if X is in A and B. See the difference? Back here in union, it has to be in at least one. For the union, it has to be in both. So let's just look at this example. Take these two sets up here. Take A and B. I've written them down here. And let's find the intersection. Now, for a number to be in the intersection, it has to be in both sets. So look for the numbers that are in both sets. What about 0? That's only in A, so that doesn't work. What about 2? Well, 2 is in A, and it's in B. So 2 we're going to include. What about 3? Well, 3 is in B, but it's not in A. All right, so it's not in both. It has to be in both. What about 4? 4 is in A and B, so 4 is going to be included. So put in a 4. And what about 5? No, 5 is not in A. It's in B, but not in A. It's not in both. And what about 6? 6 is in A, but not B. All right, so that's our intersection. All right, so I might add here that what about this? What about 4? Is 4 an element of A intersect B? Now I'm coming down here. I'm going to try to, we just want to get a feel for what this means. 4 is an element of A intersect B. Now I'm going to say that's true since, now see what it says here? It says X is an element of A and X is an element of B. So I'm going to say this is true since 4 is an element of A and 4 is an element of B. Now we're finally to our problem. Here's what we want to find up here at the top right. B union intersects C. All right, so now we've got parentheses. So I've written the problem down here. I want to find B union A intersects C. So I've written them down just so they're right in front of me. Here's B. Right, there's B. Union, parentheses, A, intersect C. Right, here's A, and here's C. Okay, now let's work inside here first, right? We have parentheses, so we're going to work inside here first. So I'm just going to rewrite what I've got here. So I'm going to write, here's B, 1, 2, 3, 4, 5. And we're going to union that with, now can you see the intersection? The intersection, remember, is just the common elements. So what are we going to put in here? What's common to both A and C? It has to, that whatever you put in here has to be in both A and C, both. So 0, no. 0 is not over here. 2, no. 4, no. 6, no. Geez, there's nothing in common here, all right? So there's nothing in common, so I just got a blank here. It's just a blank. We'll talk about that in just a minute. Let's finish the problem. Now, I've got nothing in here. Now, union that with this. Now, remember what the union is. The union is everything in here along with everything in here. Okay, so just take everything out of here and everything out of here, pour them in together. Now, I've got the 1, 2, 3, 4, 5. And now I've got nothing, all right? I'm taking this set, pouring it in here. It doesn't add anything. So that's it. So this one here, this is our B union A intersect C. Now, for sure, we need to talk about this. We need to talk about this one right here. Now, if you already understand what it is, we're done. But if you don't quite get this, let's talk about it now. This is a discussion on the empty set. Now, the empty set, right, I'll point it up here, the set with no members, nothing in it. It's called the empty set or the null set. I like to call it the empty set, so that's all I'll say. It's the empty set. it's denoted by this symbol right here. So in our last problem, here's what we got. We got a set with nothing in it. Now we're going to call it, you know what, I'm going to write it equal. I'm going to say equivalent to, just another name, just to rename it. I'm going to name it like this. Now that is not a zero, kind of a zero, but again, it's its own font, and it just means the empty set. The empty set. And it's just the set with no elements. So back in that last problem, let's look at it again here. In that last problem, when we took A intersects C, all right, here's A, here's C. Now remember, it's the intersection. There was nothing in common. Did I get it right? 0 is not in both, 2 is not in both, 4 is not in both, 6 is not in both, 3, 5, and 7, and 1 are not in both. So there's nothing common between these two sets, so I got nothing here. Now, I could write this problem like this, okay? I have, what was this? B union the empty set. Now, if you take a set B, if you take any set B and combine it with, or throw nothing more into it, you still get B.